Here you go. We're going to start graphing cosecant and secant. So cosecant goes with sine and secant goes with cosine. So in reality, what you're just going to do basically is just, you can cross this out and put in sine, and you're just going to graph sine, and then you're going to do some changes here. So basically the x values will stay the same. So what's going to happen is your phase shift, if you have a phase shift, it's going to move it left and right, and vertical shift moves it up and down. Alright, so phase shift is basically your D, and vertical shift is just your C. Period has to do with your B, right? And then amplitude or vertical stretch has to do with your A. So your A is 4, your B is easy, it's on the outside, right? What's being multiplied by X, but it needs to be on the outside of these parentheses. 3, your phase shift is what's being added to or subtracted from X, but it's always the opposite, just like on quadratics and absolute value and logarithms and all that, right? So it's a positive pi. And then your vertical shift is anything being added to after you multiply, right? Because the very first thing is you take your x, or your angle, and you subtract pi from it. Then you times that by 3. Then you take the trig function. Then you multiply, and then there's anything being added to or subtracted after that. There's not, so that is 0. Okay. So what I like to do first is just graph the y values, because that's just a little bit easier. Okay. So y values of sine, that's where I start, right? Y values of sine. We'll start there. Values are 0, 1, back to 0, -1, and then back to 0. Alright? And then what we're going to do is we're going to multiply now by 4. I'll stay with green. Multiply all these by my A. So we still get 0. This time we get 4, we get 0, we get -4, and we get back to 0. And then we're going to add our C, which doesn't change anything, so those are all our y values, right? So 0, we'll just say this is now 4. Let's work these intervals here. 4, back to 0, down to 4, and back to 0. Okay, so that's what our graph is kind of going to look like. And then I'll go ahead and graph it. So that's what the sine would look like. Now cosecant actually, what it does is, if we look at these original zeros, and sine and cosecant are reciprocals, right? So we would have to flip those fractions. So that'd be, instead of 0 over 1, when I flip it, I'd get 1 over 0. So that's undefined, right? So we have what we call vertical asymptotes through here. Right? And now what's going to happen is our graph here is actually going to flip, and it's go the other way. Instead of facing down between this, we are now going to face up. So what you don't want to do, I kind of said this maybe in class, that you just take these and you flip these fractions. Well, I don't really want to flip this fraction, because what I'm actually doing is, after I put in my x value, and then I subtract pi, then I times by 3, then I take the trig function, right? And after that I multiply by 4. So this ending spot is after I take the trig function. This is after I take the trig function. It would already be flipped before I multiply by 4. So that's why I don't flip these and get 1/4 and then mark down 1/4. Alright, so that's why I stick with the 4. Okay, so we're going to go ahead and flip these, and if you want to, you could put in just normal cosecant of say pi 4th, or actually an easier one is pi 6th. So sine of pi 6th is 1/2. So normally, normal sine, this would be normal sine, right, at 1 and -1 and 0, 0, 0. So at pi 6, which is actually probably somewhere near this, you'd get 1/2, which is right. I erased it. That's okay, right there. But when I flip that to cosecant, I get a 2, right, of pi 6th. cosecant of pi sixth is 2, so that's somewhere way up here, right? So that's why it flips, and then you can see if you put in 5 pi sixth, it would also be up here at 2. So that's why it kind of flips and goes the other direction. Other direction, other direction. Okay. Erase that. Alright, so now let's make this thing go up. So we're going to erase this, so make sure you erase this. Alright, so that doesn't exist anymore. So now instead of going down, we are going to go up. So we go up. So instead of a hill, instead of a hill, we have a valley, and then down here, instead of a hill, or a valley, we're going to erase that. And now we're going to have a hill. So we go the other way. Like that. So that's what our graph's going to look like. Now we need our x values. Right, and that's where all this rest of the information comes, that b and d. So, we are going to take our x values. First we need to take our period, which normal cosecant is the same as sine, that's 2 pi. We're going to divide that by our b. Our b is 3, so that's 2 pi over 3. So that's our period length. So from here all the way across to there, one period length is 2 pi thirds, right? And then we want to divide that in 4 even sections. So to get our interval length, we go ahead and take that period and divide it by 4. So we are going to take our 2 pi thirds and divide that by 4, which is the same as taking 2 pi thirds and multiplying by 1/4. So we get pi sixth, or 2 pi twelfths. Fine anyway, right? So that's our interval length, so that's the distance between here and here, between here and here, here and here, here and here. Okay, so now we have to find out where do we start. So where's this beginning? Normally we begin sine right here at 0. Our x is 0, right? X would be 0, y is 0. Well, now that's going to change because of that d, that phase shift. It moves our graph over, just like on a logarithm or a quadratic, right? If something's being added to the x or subtracted to the x before you take the function, it moves it the opposite direction, left to right. So this is going to move it pi over. So we normally start at 0. So we have our start normally at 0. We're going to add our d to it, so that means 0 is plus pi, so we get pi. So basically, sine, cosine, cosecant, and secant all start at d, whatever your d is, whatever's being added to the x or subtracted from the x before you multiply by your b and before you take the function. So it's always going to be your d there. So we're actually going to start this at pi instead of at 0. Then we're going to add our interval length. Well, our interval length is pi sixth. So we're going to take where we start. So x values. We're going to take pi and add our interval length, pi sixth. That means we need a common denominator, right? So we can put 1 under this, and I get pi, or 6 pi over 6 plus pi sixth is 7 pi sixth. Okay, and then we can take that one and add another interval length of pi sixth, because that's our interval length, it's 8 pi sixth. Add another one, what you want to basically get is 5. You want to do your start and then to your 4 more, so 5 total x values. So next one, 8 pi sixth plus pi sixth is 9 pi sixth, and then after you're done with this you can reduce them, but really I don't care if you don't. 10 pi sixths or 5 pi thirds. Okay, so then we can put those in there. So we start at pi and we get 7 pi sixths, 8 pi sixths, get my 9 pi sixths, and 10 pi sixths. Right, and our initial one was pi. Now our y values, I forgot to put those in there, but it goes 0, 4, negative 4, 0. Right, so we can put those, this would be 4, this would be 0, this would be negative 4. So there's my graph, all done. Okay, so here's another one. Y equals 5 secant 2x. So really you're going to just graph cosine and then invert or flip it. You're not actually flipping it over the x-axis when I say flip it. You're just changing your midline wherever it crosses the middle to those points would be vertical asymptotes, and then your hills turn to valleys and your valleys turn to hills. So that's kind of the easy way to explain it. So what this 2 times x means is, normally say if I put in pi halves, right, I get an answer of 0 when I just do normal cosine. But here, when I'm timesing my angle by 2, so that's making the angle even bigger. So that means I'm actually going to be at pi, right? So I'm getting to my angle. Normally I'd be here, but because that's times by 2, I'm actually reaching my y value faster. Right? So normally I get to my y value at 0 at pi halves. Well, now I'm getting there a little bit faster, right? So that's kind of how this works. I'm going to get to that value faster than what I normally would get to. And this would actually be 1, right? So this is, so at pi halves, we're at, say, 0, right, normally. But when I put that pi halves in here, cosine of 2 times, these 2's will cancel out. So basically, when I plug in pi halves, I'm actually plugging in, I'm not actually plugging in, but my answer looks like cosine of pi, which is actually at 1, right? When normally I'd reach 1 out here, so I'm actually reaching my answer faster. So that's why it's 2 times, basically 2 times faster, right? Okay, so let's go ahead and take care of y values first. So y values for cosine are 1, 0, negative 1, back to 0, and then back to 1. Right, and then we're going to multiply by our a, which is 5. So that becomes 5, 0, negative 5, 0, 5. Then we add our c, but we're not adding, after we multiply by our a, we're not adding anything, so that's 0, so they'll stay the same. So basically, here are our points, right? Let me do a different color here. 0, or 1, 0, negative 1, back to 0, and then back to positive 1, right? That's what normal cosine looks like, and then it's a little curvy through here. So something looks like that. And then instead of being 1 up here, it's now going to be a 5, and down here is going to be a negative 5. And this is still 0, right? Basically, if you have a vertical shift, you just, after you do this, then you just add those numbers. So if it was, say, I had plus 1 out here, something like that, and then this would just become a 6 up top, then my 0 would become 1, and my negative 5 would be negative 4. So that's why I like doing y values first, because usually don't take much to do it, right? Okay, so now we're going to just go ahead and find our x values. So to find x values, first we have to find our x start. And that is, well, you don't have to start here. You can find your period first, right? But we can do our x start, which has to do with our phase shift. And we have nothing being added to or subtracted from the x, right? So our phase shift is actually 0. So our d is 0. So d equals 0. This was a, this was c. We'll go ahead and do our b. Our b is 2. So we start at 0 and we're at our d, so we still go at 0. So this is a 0 for our x. Now we have to add our interval, right? Our interval length, first we need our period. And normal sine is 2 pi. We're going to divide that by our b, which is 2. So we just get pi. So that means it's going all the way out to pi, right? Because 0 plus pi would be pi. So the whole distance here is pi. And then we can find our interval length by taking that period and divide it by 4. So we get pi fourths. And then we continually start at our starting point. which is 0, and then we add. So this is our second dash would be pi fourths. Add another pi fourths, we get 2 pi fourths. We get 3 pi fourths. And we get pi. So there you go, just like that. Okay, so here's another kind of easy one too. Y equals 4 cosecant 2x, so same times it's 2 times faster. My A is 4, my B is 2. So that's not your period. If you want to write down your period there, I'm just writing down my B, which has to do with your period. Phase shift is 0 again, because nothing's being added to the x or subtracted from it. Vertical, nothing being added at the end, so that's C equals 0. Okay, so you can do your y values. Cosecant has to do with sine, and sine is 0, 1, back to 0, negative 1, back to 0. Then we multiply those by our a, so we get 0, 4, 0, negative 4, 0. We put those on our board. So up to 4, 0 in the middle, negative 4, 0, 0, 1, 0, negative 1, and back to 0. Draw a smooth looking curve. Alright, it's like a wave-like pattern. Okay. So there's one period length. If I ask you to do 2 period lengths, you just keep on continue with that. This rotation 0, 1, 0, negative 1, 0, 1, 0, negative 1. And it keeps on going forever, just like that. Okay. X values. So we want to find our period. So period. Take 2 pi and divide it by our b. So we get pi. We find our start, which is basically our d, which is 0. So we're going to start at 0, and then we're going to add. Oh, you know what I didn't do on the last problem? I didn't switch it. I just graphed cosine, right? Oops. I'm pretty sure people are probably asking the question, what happened on the last one? Oops, sorry. I'll come back to that one. Okay, so we add our start at 0, and then we add our interval length. Well, our interval length is taking our new period and dividing that by 4, so pi fourths, then we continually add that pi fourths to our start, so pi fourths, 2 pi fourths. After you're done here, you can go ahead and reduce it if you want. You could leave it always, and then pi. Okay, now I go ahead and actually finish it. So now we're actually, this is the graph of sine, right? This would be sine 4, y equals 4, sine of 2x. Well, we're doing cosecant. So that means all our original zeros, all these original zeros would be undefined. Okay, so let's go ahead and put vertical asymptote. So that point actually no longer exists there. There's not actually a point there. But it's okay if you go ahead and leave it. But just know there is actually no point there, right? Because that's why you have a vertical asymptote. Okay, and then our hills turn to valleys. And our valleys turn to hills. And then you just need to make sure you come back. Always come back and erase your hill. It will no longer exist in there. Okay, let's go back and fix this other one that people are probably annoyed with me. Okay, so we got to turn all our original zeros back to undefined. Okay, so this was a 0, so that's undefined. This was a 0, so that's undefined. So even after you add your C, your original zeros are the undefineds. Now let's turn our valleys. This would be kind of a half a hill, so we want to go the other direction. This is a valley, so we want to turn it to a hill. This is kind of like a half a hill, so we'll turn it to half a valley. And then we just need to erase these ones. Okay, now I fix this one, sorry. Now I actually graphed it. Okay, so now secant deals with cosine. So cosine y values are 1, 0, -1, back to 0, back to 1. Then we times them by our a, right? 2. So that becomes 2, 0, negative 2, 0, 2. We add our c. There's nothing being added to after we multiply by our a. Right, there's nothing out here. So c equals 0. So it stays that. So here, down here, and this is 0. Let's put it on the inside so you don't get confused, people that just looking at it and not watching the video. We have our intervals. Okay, so we go 2, we go 0, we go negative 2, back to 0, back to 2. We can draw our graph. A little curvy. Now we come through our original zeros become undefined. So this becomes undefined. This becomes undefined. You can go ahead and switch your valleys to hills. Or sorry, hill to valley, I guess. And a valley to a hill, and a hill to a valley. Erase these other ones. There you go, so that's what our graph's going to look like. Now we just need our x's, and again, these are actually not really points in there. So if you want to erase those points, go ahead. If you leave them in there, that's okay. Okay, now our x values, right? What does really cosine start? Because this is secant, so really we're looking at cosine. So cosine normally starts at 0. But we need to add our d, right? Our phase shift. Well, what's our d? Our d is opposite of the inside, right? What's being subtracted from it or added to it, but it's opposite. So that would be pi. So we're actually going to start pi instead of 0. Now we need an interval, so that means we got to use our period. That means we got to find our b. So what's being multiplied by x? Just 1, right? And there's nothing on the outside here, so that's fine. It's still just 1. So our period will still be the same, right? Because 2 pi divided by 1 is still 2 pi. But this got shifted over pi, right? So this distance from here all the way across is 2 pi. But I'm starting at pi now, so I'm actually going to end at 3 pi, right? And we're going to see that when we do our intervals here, at our interval. So our interval length is taking our period and divided by 4. So we get pi halves, or 2 pi fourths. Now we start at our new start, which is pi. And we go ahead and add our interval. So that means we need a common denominator. So that'd be 2 pi over 2 is 3 pi halves. So this first one here is 3 pi halves. Add another pi halves, that would be 4 pi halves. Or 2 pi, right? And then 5 pi halves. And then there's 6 pi halves, right? Which is 3 pi. Or 6 pi halves. Hopefully people can see that. Let's erase that. Or 6 pi halves. Okay, so there you go on that one. Okay, so here's a little more complicated. Your a equals 3. Your period we'll find by taking 2 pi and dividing by our b, but our b is, what's on the outside here, is 2. Right, it needs to be on the outside. It's still being multiplied by x, but it would be also that 2 would also be multiplied by that 3 pi over 4. So, and then our phase shift is what's being added to or subtracted from x before you multiply by your b, right? So that's why, and it's always the opposite, so it's actually positive 3 pi over 4. And then our vertical shift is nothing yet, still 0. Okay, so we're looking at cosecant, so that's sine. Y values are 0, 1, 0, negative 1, 0. Okay, multiplying by your a, that would be 0, 3, 0, negative 3, 0. Add your c, which is 0, so that's not going to change. So this will be 3, this will still be 0, this will be negative 3. And then it goes 0, 1, or 3 now, back to 0, down to negative 3, and back to 0. So we can draw our graphs. Now we can go ahead and, I don't know, maybe say invert it. Maybe that's a better word. So your original zeros become undefined. Right? Undefined, undefined, undefined. Okay, and then your hills become valleys. And your valleys become hills. If you actually started your graph, right here, then and cover this to the left up, you could see that actually kind of looks like the cosine one, right? Or not the cosine one, but the secant one. Okay, onward. Now here, we can find our starting point, which is just d, right? Basically, because 0 plus d is d. And our d is 3 pi fourths. So we're going to start at 3 pi fourths here. Then we need to add our interval. Well, we need to get our interval by taking our period length, which is normally 2 pi, and dividing that by, maybe I should write the word pi, or period. Pi divided by our b, which is 2, so we get pi. And then we're going to divide that for our interval length. We're going to take pi, divide that by 4. And now we can go ahead and start adding from our start. Plus our pi fourths. Oh, that's nice that we both have denominator 4, so now we have 4 pi fourths. Which is the same as pi. Add another pi fourths, that's 5 pi fourths. Add another one, 6 pi fourths. And 7 pi fourths. Alright, and if I would subtract 7 pi fourths minus 3 pi fourths, when I get 4 pi fourths, which is pi, isn't that my period length, pi? Okay, so there is that one, all done with that one. Okay, so for this one, secant, which is cosine, right, basically. My a this time is negative, so we get to see some negatives, how they look. Alright, period, this one's a little bit harder, but what's being multiplied by x is 4, so our b, it's not our period, but our b is 4 for now. Our phase shift, this is where we gotta really work. So that d is not going to be 3/4 or 3/4 pi, okay? Because I got to take this, I got to take that 4 out. So I got to divide by 4, and dividing by 4 is multiplying by 1/4. So I get 3/16 pi. So my d is actually equal to 3/16 pi. So basically you could rewrite this as y equals -2 secant 4 on the outside, and then the x plus 3 pi over 16 plus 2 at the end. So that's what it would look like if you take the b on the outside, right? Because if I multiply that in, it would be 4x, multiply that by the 3 pi over 16, that's where I get my, back to that original. Alright, so 3 pi 16ths, that's my b, or that's my d, sorry. So 3 pi 16ths. And my vertical shift now, I do have a vertical shift. Alright, so we got something changing. Alright, we got to factor out that b. Now we have a negative vertical shift, right? So that's basically flipping over the x-axis. And then we do have a vertical shift. So that's kind of nice. Changing it up here. Alright, so we're graphing secant, so that'd be cosine. Oops. And cosine's numbers are 1, 0, -1, 0, 1. Now we're going to multiply that by our a, which is -2 this time, so -2, 0, +2, 0, -2. Alright, so a little changing there. So, and then we're going to add our c, so now we're going to add c. So that becomes, and our c is +2 or -2? So that's +2, +2, +2, +2, +2. And so we get 0, 2, 4, 2, and 0. So this might be confusing. Where do I put my numbers? Well, you just put the one up here is the largest, right? So that'd be 4. That'd be 2. That would be 0. 4. Before you added your C, you could have plugged those in as 2, 0, -2. And then you could have added your C in 2, so that this would become 4. This would have became 0 plus 2 is 2, and -2 plus 2 is 0, right? So either way is fine. Okay, now we can graph those, right? It goes 1, 0, -1, back to 0, back to 1, right? That's fine. Okay, and then draw our smooth curve here. Oops. Now I really have to look at those original zeros as undefined. Because here, this one's 0 on bottom, right? This bottom, lowest one. So I don't change that to a vertical asymptote just because the y value is 0. I'd take my original zeros and make those vertical asymptotes. Okay, and then I change my hills to valleys, valleys to hills, and my hills to valleys. Okay, then erase that. Erase the cosine. Again, if you want to erase those periods, you can. It's fine. Oops. Erase that hill, or half a hill. Okay, now my x's, right? This is where it gets tricky. We did a lot of work on the d, so that's good. So our start is at d, which is 3 pi 16ths. So here you have to really work with fractions. 3 pi 16ths, because now I got to add that interval length, right? So let's go ahead and find that interval length as we take our period, which is normally 2 pi, and we're going to divide it by our b, which was 4, right? Yeah, which was 4. I do pretty good. Okay, so you could reduce that. You might not reduce this just because we need a common denominator of 16, so you can reduce this by halves, but you might not want to because we need that common denominator eventually. And then we got to divide that by 4. Alright, so to find the interval length. So I'm going to take this 2 pi over 4, and I'm going to divide that by 4, which is the same as taking 2 pi over 4 and times it by a quarter. Or I could take the 1/2, divide that by 4, which is the same as taking pi over 2 and multiply by a quarter. Right. But I kept with this one because right now I get a 16, so now I have a common denominator and I don't have to do any extra work. This one I would, right? I have to multiply top and bottom by 2 to get that common denominator. Okay, so now I'm going to add my interval length. So 3 pi over 16 plus 2 pi over 16 equals 5 pi, or j pi, no, it's a 5. It's a beautiful looking 5. Over 16. Nope, it's starting to get sloppy. It's getting late. So this becomes 5 pi over 16. I can add another interval length, which is 2 pi over 16, so that's 7 pi over 16. This becomes 9 pi over 16, and this becomes 16, 11 pi over 16. There you go. See, really complicated, but just got to work through it. You know, factor out that b to begin with. Then you got to find your period. Take the normal period, 2 pi, divide it by your b, which is 4. Then you gotta divide that to find your interval length by another 4. And then you have to start adding with common denominators, right? From your starting spot. Okay, a couple more. Okay, so here's another kind of difficult one, right? Because our b is on the inside, so we got to divide that b out. Remember, dividing by 3. So my d. So my d would be 2 pi, because remember, if it's negative in here, it's actually the opposite, it's positive, right? Which, another annoying thing, I just messed up on the last one, right? Because I put a positive 3 pi over 16 when it should be a negative 3 pi over 16, so that's going to change our x values. I'll go back after doing number 7 here. So I multiply by 1/3, pull that b on the outside, so that means it would more look like this, with that 3 on the outside, and then a 2 pi over 9, and then minus 1. Okay, so now I have my d, which is my phase shift. Now it is positive, right, because that is a negative, so make sure I get this one right. 2 pi over 9. My c, my vertical shift, is a -1. My a, I don't have an a in front of this, right, so that's actually not 0, because then you would have just a straight line, but it is 1. And then my period deals with my b, and my b is 3. Okay, so we'll go ahead and take cosine, right, because that goes with secant. So that goes 1, 0, -1, 0, back to 1. Okay. Now then we're going to times it by our a, which is 1, so that doesn't do anything. So we got 1, 1, 0, 1. And then we're going to add our c, which is a -1. So this just becomes 0. This becomes -1. Ooh, that works. Could leave that green writing right there, but I'll put -1. And then this becomes a -2, right? Because it was -1. It was -1. Now it's going to become -2. Oops. -2. Okay. And it goes 1, 0, -1, back to 0, back to 1. Right? So then we can draw our smooth looking curve. Then we can do our vertical asymptotes where our normal zeros were. Change our hills to valleys and our valleys to hills. Erase those. Oops. Can erase that too. There you go. Okay, so that's what our graph's going to look like. Now we can find our x's. Remember, we start at our d, which is 2 pi ninths, a positive 2 pi ninths. Then we're going to add our interval length, which is our period, which is taking our normal period and divided by b. So that would be 2 pi over 3. And then we got to times that, right, to find our interval length, we got to times that by 1/4. So that becomes 2 pi over 12. People probably reading this are going to be confused, but that's alright. I've done so many of them that I'm kind of getting tired of doing them. But I'll come back and correct that one. Now we need a common denominator, right? So, what's that? 36. So I gotta multiply this one by 4, top and bottom, and this one I gotta multiply by 3, top and bottom. So we get 8 pi 36th, and I get 6 pi 36th. Okay, now we can add them and we get 14 pi 36th. So we start at our, here would be our d, which is 2 pi ninths. We gotta add our interval length. So add, we did that. That's where we got this 14 pi 36th, and I wouldn't even reduce it. 14 pi over 36. So keep those 36 and add our 6 pi over 36. So that's 20 pi over 36. Add another 6 pi, so 26 pi over 36. And then 32 pi over 36. So that one's really complicated. Now let's go back fix my mess up because that should be a negative. A negative, right? D is negative. Negative. So this is positive, so it's negative. Now we have to go back down here. So that's a negative. It's a negative. So this is a negative. So negative 3 pi 16ths plus 2 pi 16ths is actually a 1. Negative 1 pi 16ths. Negative 1 pi 16ths. So let's switch this. This is negative pi 16ths, and then I have to add 2 pi. Negative 1 plus 2 would be a positive 1. So this is pi 16ths. And I can erase this one. Add 2 more, that would be a 3 pi. It would be the same, because eventually I get to 3 pi over 16. That's where I started right here, right? So eventually it does catch up. Luckily, because my period length is the same, right? So this becomes 5 pi. So it would have been okay to leave it. But I'm sure people got confused probably when they're like, it says positive, but you put a positive. Aren't you supposed to switch it? Yes, I was. It's getting late. Okay, so fix that one. Alright, one more. Alright, last one. Go fast. Ready? Go. See if you can beat me. Negative 3. 1. Negative pi fourths. C equals 3. Sine is 0, 1. Back to 0, back to negative 1. Then I multiply it by negative 3. So that'd be now turn to a 3. 0, negative 3, and then I add 3, so that'd be turning actually to 6 now. 6, then I could turn to add 3 to 0, that'd be 3, add 3 to negative 3, that'd be a 0. And then it goes 0, 1, negative 1, 0, or 0, 1, 0, negative 1. Back to 0, right? And then my zeros are going to become vertical asymptotes. This was a hill, now it's going to be a valley. This was a hill, this was a valley, so now it's going to be a hill. Oops. A hill. There we go. Erase these points because they no longer exist there. Alright, now I need to find my x's. It starts at d, which is pi fourths, and then we gotta add our period, which is 2 pi over 4. Actually, it's actually just 2 pi, right? Because 2 pi divided by b is just 2 pi, but then my interval would be 4. So I'm adding my interval already. See, I'm already ahead of the game here. Start RD, which is, oh, I see, I almost messed up again. Negative, right? It's negative pi fourths. So I add 2 pi to that, 2 pi over 4 to that, which is just pi fourths. But eventually see how I got to pi fourths. So it would have been okay. Actually, it probably wouldn't have been okay. Because at pi fourths, I actually start at 1, or negative pi fourths. I have it undefined. So yeah, so that previous one that I messed up one, I actually probably couldn't have left it the same. Because I would have a different start point. So yeah, there we go. Add another, that's 3 pi fourths. Add another, that's 5 pi fourths. Add another, that's 7 pi fourths. And all done. There you go. That's how it looks. All done with this video.